Okay, so we're going to talk about volume of prisms today. We've written a couple things down already, and we're just going to talk about them. First shape we have is a rectangular prism, okay, which is this guy here. This looks like a square, this object. We're going to call it a rectangle. It's a four-sided shape, okay? It is a rectangular, and the reason they call it rectangular is because the face of it is a rectangle. Now, to find the volume of it, it's base times height times width, or sometimes we refer to it, as depth. We called it depth, or in this little formula here, we've called it width. And we've color-coded it. This is the base of the object times base times the height, which is here, times the width or depth, which is this. Okay. The reason I use the word depth is because I want to show you another way to find volume of a prism. Another way you can find volume of any prism, okay, is the area of the face times the depth. So this is volume of any prism. You just have to figure out what the face of the prism is. So here's the face of the prism. Okay, it's our rectangular. And area of the face. Well, the area of a rectangle is just base times height times the depth again. So we find this face here. This is the area of our face. And then we just multiply by the depth of this. Because we know the shape is the exact same as the face all the way back there. Okay? Almost think of it like you're stacking slices. Here's one slice. Here's another. Here's another. So maybe this width or depth is 4 deep. So we find the area of this, and then we just multiply it by 4 to get all the way back. Okay? It's almost like slices of something. So with that same idea, I can just write out the formula for a triangular prism volume. We can do that very quickly. Triangular volume of a triangular prism is half of base times height times, we'll call it width again. Okay, so we're getting a little harder to remember. But another one, or we keep that same formula we had before. Volume is the area of the face. Copy. Okay, area of the face. Oops, let's undo that. Stop. Okay, so again, area of the face times the depth. And what we mean by that is, what would the face of a triangular prism be? What shape would be the face? Exactly, the triangle will be the face. So we're going to just highlight the triangle here. Okay, so here's our triangle. This is the face. And we find out what the area of this face is, and then we just multiply it by how deep it goes. That is always going to work for a prism, okay? So this is going to be our depth again, or W or D. In this case, we're going to call it D, okay? Just so you get the idea. It could be W, it could be D, it's up to you. Area of this face. Now, the problem is area of the face of a triangle. Do you know the formula for area of the face of a triangle? Or area of a triangle, I should say.
This one.
Yeah, you're right. It's right above what we have. We'll put those things in, the base and the height again. This is considered the base, this is considered the height, right? And we use those same highlighters. This is our base here, which would be just across that part. Our height is this thing here, which would be just up and down here. And you're exactly right. This is considered the area of a triangle, that part of the formula. So instead of actually memorizing every volume formula separately, entire page, okay, we got to 2 of them. We're going to jump, actually, you know what, we'll jump to the 3rd one before we talk about this general idea. Okay, so we got that. You're right. It's the exact same thing. Here we go. Now, cylinder. It doesn't say prism, but this is essentially a prism in itself. What would the face of this cylinder be?
Circle.
Yeah, exactly. So again, we're going to just highlight the face of this. Okay. And this would be pretty much our depth. Okay. Now, they're going to write the formula out a little differently, but we're going to write it our way first. Our base. Here we go. This is our volume of the face times the depth, right? Now, what they usually do is they usually refer to this as the height of the cylinder, okay? And area of the face. So we got to think of area of a circle, okay? Area of a circle is pi r squared, Okay, that's the area of a circle times the height is considered.
That's the radius times 2. Right?
Exactly. The volume. The volume of a cylinder is pi r squared times height. Or in this case, the same as below, area of the face times depth. We know that this is the face of the object, just like the face of the triangular prism was the triangle. The face is the circle in this one. So area of a circle is exactly that pi r squared part. Okay? So if you can continuously distinguish what the face of the object is, it's actually really easy. We don't have to memorize all of these formulas in terms of volume. As long as we remember our area formulas, we're okay. So if I remember the area of a rectangle, which is base times height, I got that part, and I just multiply by the depth.
Mm-hmm.
If I can remember the area of a triangle is base times height times a half, right? And that's the reason that is because a triangle is half of a square, right?
Yeah.
So it's base times height, same as the square, just multiplied by half, because it only takes up half the space.
Mm-hmm.
And then we just multiply by the depth. And then area of a cylinder. Well, the face is a circle. Okay, so I'll draw a little thing for the radius here. This will be our radius. Radius is from the center of the circle to the outside. Okay, so that's our radius squared. We square that number times pi. That's the area of a circle, which is the face, and then we just multiply it by the depth again, which is, they call it usually the height, but in this case, it's the rest of the prism. So all of these are types of prisms. Square based, triangular base, a circle base. You could say a circle based prism, but they normally call it a cylinder. That's the mathematical term for it. Okay. Okay. One other thing just to talk about is when we finish our units, when we measure something, our volume is equal to, let's do it in black here. Our volume is equal to some number, and then maybe units. So units is either meters, or it could be centimeters, could be yards, right? But they're always cubed, okay? And that's the very important part, okay? The reason it's cubed, is because we're talking about 3 dimensions, okay?
Oh, yeah.
Right?
Oh, yeah.
Area just talks about up and down, base and height. It's almost like, remember playing old Mario? Have you ever played an old Mario game? You only move left to right. That's 2-dimensional. New Mario games, or a lot of new video games today, talk about 3 dimensions, right? And it's what we live in. There's a base, a height, and a width. So we're talking about 3 dimensions, and that's why we put it cubed. Area ends up being squared because it's only 2-dimensional, height and width, and that's it. Okay, so that's the reason we put cubed for volume and squared for area. Okay, the next thing we're going to talk about is area of pyramids. Or sorry, not area, what am I saying? Volume of pyramids, okay? So the first object we have is a rectangular base pyramid, okay? Now, just like we had an overriding formula where we said area of the face times the depth was for a prism, for a pyramid, it's area of the face again, the height, which is I've drawn with a red line, the height of the object, which can still be considered the depth, right? If this is the face, we know that the depth would be how far deep it goes. But because it's not a solid object like a prism, right? The height of it would give us a solid depth. We have to actually multiply by 1/3 because it doesn't actually take up all of that space. So we multiply that height by 1/3. So each of the volumes is going to vary pretty much depending on the area of their face. The heights will all be the heights, and we always have to consistently multiply by 1/3. So the volume of a rectangular base prism, we're going to figure that one out now. So how do I find the volume? What is the face of this one to start off?
Triangle.
Is the face a triangle?
A square.
Yeah, okay. And I guess by face, I could have wrote the word base down. I try to keep it consistent like the last one, but this is what I mean by the face. This is the base of it. You know what? I'm going to change that word to base just to make sure we're consistent, okay? That is no longer face. It is now the word base, just so it makes a little more sense with what we're writing. There we go. Area of the base, okay? So how would we find the area of this base, to be exact? Yeah, right? So if this is our length and this is our width, okay? Area of the base is the length times the width, times, this will be our height. We know that, okay? So times the height, and we have to multiply by 1/3. So that's the volume of this pyramid. Now it looks complex, but really the area of our base is just these two guys here. Our height is our height, and our 1/3 is our 1/3. Okay? So using the same type of formula down here, we're going to do another type, triangular base pyramids. And again, because this has the old face in it, I'm just going to erase that part and put the word base. Okay? So, what is the base of a triangular base pyramid? What would the base of this object be? I've given us two examples.
Base. Oh, right there.
What shape is it?
The triangle.
Yeah, it says it right in the name, right? So we're going to highlight both of them here. So this is this base here. So we're going to find the area of that base, and in this one it's a little different looking. It's kind of from a different angle we're looking at it, okay? Triangular base pyramids can sometimes be harder to visualize. So we have the base of that one. So the area of the base. Okay, so area of the base. If this base is a triangle, what is the area of a triangle is what we're trying to say here. Volume equals, what is the area of a triangle?
Base times height.
Yeah, base times height and then something else included in. So we'll call this a base and this the height, or in this one, this will be the base because these do make 90-degree angles. And here's our height. Oops. What what else is part of that formula? Well, let's say that's a 90-degree angle. So
I said base times height. So, half. 1/2.
yes, that's right. If that's the base, this is technically the height of this triangle. Here's our height. And we'll say that this one is a 90-degree angle. So this is the height. Okay. So base times height times a half. Great. So the area of this is 1/2 times the base times the height of the triangle. Okay. And that's the area of the base itself. We still have to multiply here. I know the red one's a little hard to see now in this one. But that's the height. We still got to multiply by the height and then times 1/3. Okay? So again, we just kind of break it down. We got to remember the areas of certain objects. So these are the bases times the height, and times 1/2 would be the area of a triangle, times the height of this object times 1/3. Does that idea kind of make sense?
Mm-hmm.
Okay. And finally, a cone. What shape is the base of this object?
Circle.
A circle, that's right. So we're going to just highlight the circle at the bottom here. Okay. Now, it's the exact same type of formula we had before. Put it in. We're going to change it from face to base, just so it's a little more consistent with what we have. And what is the area of a circle?
Pi r squared times height.
That's right. So we have our volume is pi r squared. Okay, so we're going to have to put the radius in this object here. We'll do it with a blue line. The radius will be from like here to here. That's going to be our radius. Okay, from the center of the circle is our radius. And we'll highlight, I guess, that guy in blue just so we have an idea. That's what we're talking about for radius, okay? But that's the area of the base. The area of the base, which we just figured out, is pi r squared. This is still the height. So we multiply by the height. And because it's a pyramid, we still have to multiply by 1/3. Okay? So it's very similar to, in fact, if you remember, had this been a cylinder, you know, like kind of like this instead, and had the circle object here, this would have been the area of the cylinder. Sorry, not area. Volume of the cylinder. We just multiply it by 1/3 because you see this is no longer a prism. It gets cut into a pyramid shape. So we multiply it by 1/3 because it's only 1/3 as the size. Same with this one here. This could be looked at as a triangular base prism. And in that case, this would have been the volume of it. But because it's a pyramid, we multiply by a third at the end of it. And same with this one here. We could have got a prism again. This would have been the volume of the prism, but because it's a pyramid, we multiply by that. So, entire page, that's kind of what we're looking at. Let's compare the two for a second. Okay? Now, we can't quite see all of them. But if you take a look at these objects, they're very similar except for the pyramids, or the formula for the pyramid is just multiplying by a third at the end. Okay, so you take a look. We're just consistently multiplying by a third at the end for our pyramid shapes.